Hey everybody, it's Bob Crossan, Senior Managing Editor for Water and Waste Digest, and I have for you again this week another Top Projects interview. Today I have with me Phil Bzdusek. He is the lead project engineer for Strand Associates. I also have Allison Swisher. She is the Director of Public Utilities for the City of Joliet. And I have Troy Stinson. He is Project Manager for Strand Associates on this project. And we're going to be talking about the CSO Tunnel and Wet Weather Treatment Facility in Joliet, Illinois. So thank you all for being here and congratulations on winning a top project for 2021.
Thank you.
Thank you.
Yeah, so I wanted to start with you, Allison. Could you describe a little bit about the history of the Joliet East Side sewer system, where this was constructed, and the community that you serve?
Sure. So Joliet is an old steel town. We were formed back in 1850s, but we didn't actually have wastewater treatment until the 1950s. So the East Side wastewater treatment plant is our first wastewater treatment plant, and it was put into service in 1957. So it still serves our older portions of town. It is a combined sewer system. So we have about 20% of the sewers within that collection area are still combined. And so the city has since expanded significantly. We've had a lot of westward development. So we actually have two additional wastewater treatment plants. But as I mentioned, the east side one still does serve our oldest collection system.
Hmm. So what was kind of the catalyst for this project in particular? I know that Joliet has a lot going on right now, even on the drinking water side too, but what in terms of like the wastewater side, what kind of led this project and kind of made it a focal point for you?
Yeah, well, the city had on this older collection system a number of combined sewer overflows, and so since the 70s, we've been working to address that and reduce the number of overflows, and been working on that. But ultimately, it was realized that separation wasn't going to be the answer, and so we did in the 2000s then work with the Illinois Environmental Protection Agency to develop a long-term control plan in order to minimize our combined sewer overflows to no more than an average of 4 per year. And so this long-term control plan had multiple phases. And so we began this work around, I think, 2012, 13 with the first phase. And then the second phase and third phase was the tunnel construction, and then the wet weather treatment facility.
Hmm. Yeah, I mean these types of projects I feel like are gaining a lot more prominence, especially like here in the Great Lakes region. We're starting to get a lot more rain. You really got to figure out what you're going to do with all this water, but it's also just a national thing. Like you're seeing these values of rainfall increasing dramatically. It's like how do we handle this capacity of this stuff?
Yeah, and we have like you said, this was a huge proud program for the city of Joliet. And, prior to some of the stuff we're doing right now, working on our drinking water issues, the overall long-term control plan, I believe, has about an $80 million price tag. So again, this was a huge undertaking for the city to, work through this. But like, as you said, we've been doing updated modeling to address, newer rainfall data to make sure that we're still going to be able to achieve that goal of reducing the number of overflows.
Yeah. I mean, in terms of the size and scope, Troy, could you elaborate a little bit more on that actual size and scope, what this actually like looked like? What are we talking about here?
Yeah, no problem. Like Ellison said, the overall program is about 80 million. The two projects, the two phases that we're going to talk about today is the phase 2 and 3 portions of the project, and those were about $55 million. So pretty sizable projects. The first one was the phase 2 project. I think it was probably the most interesting one. It was a tunnel under the Des Plaines River. So tunneling is fairly prominent in other parts of the country, but in the Midwest, it's pretty unique. There's not too many people that are tunneling on a project. And what we were faced with this project, the whole project team, is we had a tunnel under the Des Plaines River, and the Des Plaines River has a 1927 U.S. Army Corps of Engineers river wall on both sides, a very old structure. So the challenge that we had was to tunnel under the Des Plaines River and under those river walls that were, had some age on them. And included a siphon diversion structure where we actually had to get into that 1927 river wall and construct a structure, and included a lot of coordination with different agencies. We had blasting on the project to construct. There's a lot of rock in the Joliet area, so most of the project, almost all of the project was in rock. It included a west side interceptor. It was like 900 feet of 72-inch interceptor sewer pipe. The interceptor sewer pipe went right under the I-80 bridge, so you can imagine some of the issues we had with that. They had a screening structure, which I think we're going to talk a little bit about later. And then the tunnel itself, it was only 800 linear feet, fairly short for a tunnel, but it was about 111.5-inch tunnel diameter. And within that tunnel diameter, we actually put a 60-inch wet weather pipe and two 24-inch dry weather siphons. So during the dry weather times where it's not raining, the wastewater goes from the west side to the east side with these two 24-inch siphon pipes. One is typically used, the other one's a backup. And then when it rains, it goes through the 60-inch wet weather tunnel. Nice thing about that, I think Phil will talk a little bit about it later, is that it really uses that tunneling diameter and fills it all with structures and piping. The bid cost of that project was about $21.4 million. It was completed on time and had very little change orders. So we're really happy with that project and how things went. A lot of different people were involved in the project. A lot of sub-consultants as well were very useful in that project for us. And then the project overview for phase 3. So after we constructed the tunnel, we constructed the wet weather treatment plant. So we needed to get the flow not only from the west side, but there was wet weather flow from the east side. And we did a wet weather treatment facility. And this wet weather treatment facility was 117 million gallons per day of capacity. So pretty large structure for pumping. It included what's called first flush tanks, and first flush basically captures that initial high solids and high organic matter into a tank. So that gets treated to the east side plant for full treatment. It included primary clarifiers with 90 MGD of capacity. Those were 180 feet diameter, which are very large. They might be the largest one of the largest final clarifiers in the state. And then chlorination, dechlorination. So obviously disinfecting the wastewater, the treated combined sewer overflow before it gets discharged. That project was about $33.4 million project and had very low change orders as well. So I don't know if that gives you a pretty good scope, or if anyone wants to add anything to that.
Yeah, I mean, it does really give a good idea of the scope, especially with like just the size of the individual pieces of equipment. Also, that presents its own challenge in its own right, not to mention the fact that like there's a multi-year project, multiple phases, and coordinating all of that. But in terms of that coordination, what project delivery method was used for this project, and why did you guys pick that specific that method?
Yeah, so what we did was we just did a conventional design, bid, and then build the project. And the reason that was chosen is it's used very often in the Midwest. Plus, it was an IEPA loan project. We took advantage of very low interest rates on the project, and they require that as part of their program for loan funding.
Got it. Okay, very interesting. Yeah, we get all sorts of options depending on regions and stuff like that. And I know that design bid build is really popular here in the Midwest, so I was just very curious. It's a good curiosity for me. But moving on to more aspects of the actual project itself, you had talked about this screen that we were going to talk about. Could you talk about could you explain this screen? It was a horizontal hydraulic deflection screen. Why was it useful for this project, and had you ever used anything like this before in a project?
Yeah, great question. So we actually have used it before in another few facilities, but the issue we had, this project was kind of, you have the west side project on the west side of the Des Plaines River, and you have the east side on the east side of the Des Plaines River, and there's kind of two different locations for the project. So on the west side site is actually a remote site, so there's no one that's there, no one mans that site. What that site includes is the drop shaft for the tunnel. So it's a big circular drop shaft. There's a screening structure where this deflection screen is at. So the challenge we had is that we didn't want to have screens. Typically, when you remove screens from a wastewater treatment plant, you take them out of the wastewater, right? You put them in a dumpster and they go to landfill. They can be odorous. We didn't want to have the city staff visit the site after a rain event and basically take these screens and haul them away. So the nice thing about the deflection screen, what it does is it basically keeps, it screens all the wet weather flow, has to go through the screen to the tunnel. So it keeps the tunnel clean, and it keeps that wet weather pumping station clean. And it basically keeps all the screenings in the dry weather flow. and it keeps it basically they go to through the 24-inch siphon pipes and they get removed at the east side treatment plant where they already have screening facilities. So I guess the beauty of the deflection screen is it screens out the flow that goes over the weir to the wet weather side of the facility, but the city doesn't have to collect screenings on the west side, which isn't visited very often.
Yeah. So it's kind of like a logistical, easing some logistical challenges that otherwise would have presented themselves.
That's correct.
Cool. Now you had mentioned too about this tunneling and going under the Des Plaines River and going under the highway. But Phil, could you talk a little bit about how you guys ended up adapting a little bit of this tunneling during the actual construction phase? What was the reason behind that, and what types of challenges did that present to your team?
Yeah, sure. I can definitely elaborate on that. So during our project design, we spoke with several contractors. We had a geotechnical engineer involved. Given the length of the tunnel, like Troy mentioned, it's a fairly short tunnel, 800 plus feet. The conventional way to do a tunnel boring machine is to have a starter tunnel, which that is typically drilled and blasted. So the contractors were all telling us, if you drill and blast the starter tunnel, by the time you've done that, you might as well just keep going with drill and blast, because you'll be a couple hundred feet in, and what's the point of bringing in a tunnel boring machine for a couple hundred feet? So then, of course, after the project gets bid, the contractor, the winning contractor, came in and said, "Hey, we've got an idea. We've got a method where we can use a tunnel boring machine, and there's a steel tube structure that we would use as our substitute for the starter tunnel. So instead of having to drill and blast into the river, they can use a starter tunnel that the tunnel boring machine can kind of grip onto to start to drill into the rock, the bedrock below." So that was the main reason. We looked at that, and then there were some concerns associated with that. With the drill and blast method, we had specified probe drilling. So they blast 20, 30 feet, and then they drill a hole. And this hole was used to detect if there were any seams or anything where there was a connection to the Des Plaines River above. So with the tunnel boring machine, we weren't able to do that. So the contractor did a horizontal directional drill for the full length of the tunnel to check for any seams or anything like that, any potential direct connections to the river above. So yeah, that was kind of the rationale for it. It was a big change, but it ended up working out great.
So I wanted to also note the Des Plaines River and the highway, like I had mentioned. What types of challenges did those present to this like tunneling aspect? How do they differ from one another? Like obviously it's like dealing with the Army Corps of Engineers versus IDOT is going to be different too, but like, is there anything with like the soil that's different there too, and like how you have to design things and whatnot?
As Troy mentioned, the bulk of the project was on bedrock.
Okay.
So the main questions and concerns from the agencies were the methods of excavating the rock, whether it's using hydraulic excavation or drilling and blasting techniques. So obviously with the river, the big challenge was, Troy had mentioned, is going underneath the river walls. So whether, we proposed to drill and blast under them. So you got explosives underneath these walls that are going on 100 years old. And then you've also got the potential of a breach where the river could get connected to the tunnel, and then the tunnel would essentially flood out the east side. Because one of the most unique aspects of this project is the west side of the Des Plaines River is at the river elevation, and the east side, because of the river walls, is over 20 feet below the river level. So if there was a breach in the tunnel, the river could essentially drain out into the east side, flooding the east side wastewater treatment plant. So that was a huge concern of the project, and one of the reasons that we required them to do that probe drilling and the horizontal directional drill to check for any sort of large fissures or seams or anything that would create that hydraulic connection. And then with IDOT, they had a different set of challenges. They have their I-80 running adjacent to the project site, which is a major U.S. interstate. So they were concerned with vibrations, damaging the footings, the foundations, the piers for the I-80 bridge. So we had to coordinate with them on peak particle velocities for blasting, clearances, how close we could be to the footings, that sort of thing. And then the other major component was for the wet weather plant. There's a planned future expansion of I-80. So the footprint of I-80 is going to grow, and we wanted to make sure that it wasn't going to grow into our newly constructed treatment plant. So there was quite a bit of coordination with them just to verify everything was in a location that was going to accommodate the future expansion. So yeah, it was very intense project with coordination with agencies, but all of them were very responsive and worked well with us. So it was a great project from that standpoint.
Yeah. And I just wanted to add, Phil, too, I thought one of the more interesting coordination we had to do was with the Illinois Department of Natural Resources, because they had boats that would go up and down the river each day, and they would be counting carp. And so when we were doing the probe drill, we had some equipment that was in the river, and we had to coordinate with them to make sure that, they didn't, that they were aware of that. So it was just a lot of various, very interesting coordination efforts that were made for this project.
Yeah, all those small, tiny details that you don't really think about until you're like at the site and you're doing your probe drill and you're like, what is that boat doing over there? It's really interesting. Well, and I wanted to touch just quick, Phil, on the I-80 stuff. Just in terms of location, was this near a spot where there were like flyovers and stuff like that? So that was kind of part of the concern. You mentioned like these footings or whatever. Was that because it was like a part of a flyover area?
There's a large bridge that crosses just north of the site. So yeah, and that's the bridge that's planned to be expanded in the future. So we had to be very cognizant of the location of all the footings and everything for our design.
Yeah, as always, a good foundation is really important. But but thank you guys for talking about this more today, getting more of detail into all these things, some of the nuances that you guys were dealing with and whatnot. Before we end the call, I wanted to get some shout outs from you. Obviously, there's only 3 of you on this call right now, but so many more people were working on this project. I want to give you guys an opportunity to shout out some of those people. So I'll start with you, with you, Phil. Got any shout outs for people who aren't on this call today, who did some tremendous work, and people you want to recognize?
Oh yeah, absolutely. It was a huge project team, obviously, to execute a project like this. The first ones, I guess, would be 2 people from the city of Joliet who've since retired, Jim Egan, who was in Allison's position, and then Bon Moy, who was also integral with this project. The contractor team, Williams Brothers Construction did the wet weather plant. Joseph J. Henderson was the prime contractor for the tunneling, the tunneling West Side Interceptor project. Midwest Wool was the contractor that actually did the tunneling work. V3, they were an on-site representative during the tunneling project and the wet weather project. They played a huge role. Mott McDonald, they were called in as tunneling experts, so they played a large role in both the on-site work and did some assistance with finishing up the bid documents. I guess I'll pass it along to Troy and Allison if you guys have anyone else. Maybe Troy, you start.
Yeah, sure. The only thing that great Triad Engineering was kind of teamed with Midwest Mall. I'm not sure if you mentioned that. GZA Geo Environmental played a big hand in helping us with the geotechnical portion of the project. There's a lot of geotech that goes into a project like this. You actually do a lot of river borings and cores prior to the project out on the Des Plaines River. RJN Group also did some modeling for us during the project, which actually kind of basically changed some of the recommendations for the wet weather treatment facility. We made it a little bit larger. And then I obviously want to shout out to Allison, worked really well. Enjoyed working with the city of Joliet, and Nick Gornick, who's also not on the phone call today. Both of those just had a tremendous hand in assisting with this project, and I want to thank them for that. And then finally, it is Austin Tyler Construction. They worked on the West Side Interceptor Sewer as the contractor for that project. I don't know if Allison, if you have anything else to add.
I know Phil and Troy have mentioned a lot of people involved. Again, Nick Gornick, who has been, working on this project since the beginning, has been a huge assistance. All the guys at our treatment plant who have now implemented this new, treatment facility, and we have used it a number of times already, and it's been working, which is always great to see that after you finish a construction project that it works as intended. So it's definitely added a lot to our our treatment operations. So and I guess lastly, just the Joliet City Council that had the vision to see this through and supported it and made sure that it got done. So I definitely want to thank all of our elected officials.
Yeah, gotta shout out the elected officials for the vision. You gotta shout out all those operators who are now not only had to deal with the disruption that this could have caused, but also are dealing with it now. And like you said, I mean, as we're recording this, we're coming off of like what seems like 10 straight days of rain. So I'm sure that it's gotten a lot of work, and you guys have been really able to put it to the test. So
Yeah.
yeah. Well, anyway, thank you all for being on the call. And to everyone who's watching, definitely stay tuned next week. We'll have another video interview with top projects. And we will also have in the description below, we did an article about the Rethink Water Joliet project that they're doing on their drinking water side earlier this year. So we'll have a link to that down below so you can check out to see just kind of the scope of things beyond just this specific project that Joliet is working on. So thank you all for being here, and really congratulations once again on a top project.
Thank you.
Thank you.